Alright, this is Tom Eckert. We are coming at you live from Phoenix, Arizona. And this is a shout out to Grassy and DJ and Clay and all our friends up there. We're doing this specifically for a real good friend, and but I am going to go public with it just for some of the workflow aspects. We're going to run through it and then break this out into another series of screencasts for training purposes. I know when you go, sometimes it's just tip and trick, but when you go to open and you lose your recent documents, and it's like, boy, I really want to. Rather than back out and reopen, this little guy right here, recent documents, brings it back up. And this is a project in Chico, Texas. Going to jump in and to look at it and just show you the end game on what we're looking for. There's a one he's off on that. I love that. It's going to have to be a screencast all in itself. But anyway, as we're going along, we're looking at some of the enhanced performances. One of the things that we have to go over is when you are looking at a surface model, a recap file, any kind of DSM, and it is giving you just the bounding box. There is a reason for that. Let's go with just talking about here. See this bounding box? This is a display style that if you don't have your hardware accelerator in Civil 3D, you're going to get the bounding box rather than the 3D model. And so just the reason I'm jumping into this PDF, this is a 3D PDF that's real small, is it is one of the deliverables that comes out of the Pix4D processing. And it is a great way to represent the OBJ and the FBX file, which are very large. The OBJ file, with the free version of Sketchfab, which we'll go into, but the Sketchfab only handles 50 up to 50 meg. And so a little problem when they're at 68 meg, and so I thought, well, wait a second, if I get a big old pile, for whatever reason, the Pix4D kicks out about the same size. This LAS file we use as a check, but with recap, LAS is just so much smaller. So a couple of things that go on. One is this particular job, I've processed it 2-3 different ways. One thing I do want to show is on the contours. These contours, the PDF that comes out of the contours is really amazing in that it represents the DXF so well. And these are 1 foot contours. This pile is, I think we figured it was about 140 feet high or so. And we got a big old pit here. You can't see the contours of the borrow pit. But just know that when you supply the PDF along with the, let me just minimize this, along with the DXF file, right here, this guy, this is only less than 9 meg. You can really do some great ideas. So let's go through a workflow of just what happened. How do we get here? What is the real workflow? One great way to do is to start with the KML file. And never hurts to go into Google Earth. Just as a demonstration, KMZ and KML is just a real user-friendly. There's a site. There's a KML that we produced on the pit, and I guess I should go down here and turn it back on. I am not the sharpest pencil in the crayon box for sure, but so ultimately that's what we're going to looking for. Multiple flights all over it, but there was a couple that I was just comparing, contrasting some of the benefits of that. So Google Earth, obviously real important to the workflow. Everybody uses it. It's not a bad thing, but it only gets you started. And I'm going to close this out, we're going to minimize that. So then one of the next packages I go into is a global mapper. One of my favorite go-to software packages. We've got a digital elevation model that is underlying. It's all geo-referenced. Here you see, so 850 feet. We got down to 710 and up to 1,000. So pit's about 100 and some change low, and the pile's about 140 and some change high. So you have a pretty good delta going on here, at least 280 feet. Call it 300 if you want. But one thing about Global Mapper is you're bringing in online data. You can look at it in my favorite tool. So here it is. What is your favorite tool, Tom? Tell us. It's the image swipe tool. Is that underneath the area you can actually see. Let me get down here. mint. So you've got the ortho mosaic. You also have the terrain model below it, the DEM, and there's just so much data to be able to analyze that on a visual GIS aspect. It's my favorite go-to, like I had said, on just doing some simple analysis. That home, you can see how the homes pick up and actually do pretty good. The top of the piles right here as we're swiping away. And I don't know. I get the second favorite, so hey, please tell us, what is your second favorite tool? Are the simple cross sections. Just a real quick and dirty. Let's get this thing going. And we hit OK on that one. And from the property corner running across the pile, actually let me do this. The property corner here running across the pile that way. This would be a much more exciting one to have. And let's hit 2 points. 1 and 2. And so as we're looking at the profile here, this is a profile path. You can see, notice the little bouncy red X, the Mickey Mouse. There's 225 meters. I should probably change my elevation to feet. But entrance road, right? Adjacent property. You jump down this road. Here's the show. This is the road coming down. Bottom of this. Some real simple bouncy math. You can do multi-line profiles, which are just amazing. So on this path here, as you're coming up with your path where it is, this is what the site looks like. So yes, you can kick those out. Yes, you can do cross sections in that, but it's a great viewer. And finally, third favorite tool, the export capabilities. There's an amazing export. It's just a sandbox where if I wanted some of the raster and vector, I use ECW files, and lots to choose from according to seeing your 3D PDF file that does come out. But anyway, Gold Mapper, really a major asset to the workflow. So moving along, we've got then SiteScan, which produced most of this data. As you're coming in here, this is another view of the site, a little bit larger. One thing that's cool about when we actually bring in this whole site is as we're exporting this ortho, 1.2 gigabyte is what it kicked out. Highly effective. The DEM surface is amazing. It's 1.1 gig. And a little bit too hefty for Civil 3D to handle them. I had to trim it down, play with it. The point clouds, 3D meshes, all the aspects. Processing report is the subject of another one of the screencasts. So the photos themselves, all available. If you wanted to, let's go with one that's got some equipment on it. That guy right there, I think, has got some equipment. And here's the conveyor. If you want this particular photo, you can download it, do the slideshows. There's all kinds of the metadata that you've got available to you. So one last plug for SiteScan. Amazing capability when you're actually doing some volumes here is if you wanted to find out what this pond looked like, including the access road. It would be about like that. And you looked at it, it's going to calculate the square footage, your cuts, your fills, and then when you're looking at not the volume report necessarily, but the 3D itself, then you've got the opportunity to see it in baseline and the mesh itself. I'm going to turn that off in the mesh and just get you a real good accuracy of, isn't that cool? Now the water had problem with, look at what it did with the water. The water was like this muddy green. No wonder it couldn't get it, but picks up on the high wall right there. The base plane, I tried to do this in another screencast and I could not get it to work in a level base plane. And I found out why. Is when I put in the level base plane, I maybe bump it down and I come down. Let's go with what the 800-foot level. Maybe they've got permitting for above 800 feet. Real important for landfills, by the way. I have to hit save. So now when I save that and I turn the base plane on that, I can do a pretty nice cut through on what 800 feet looks like in the pond. There's everything below, everything above. So for those of you who watched the last screencast, cut me some slack. I missed that one, and but that really shows. It's pretty cool. So back to flights. We're going to have a whole one, again, a whole screencast on site scan. You want you to miss out. But so the creme de la creme. Here we are in the infamous Civil 3D. Man, this is just a workhorse for all the heavy lifting. Everything is got the Civil 3D right click. Now, last time I was doing this in the practice, the object viewer, it crashes pretty good when I had so many things open. I bet it's going to work, though, for you guys today. And sure enough, there's our pile, realistic mode, tens of thousands of points, all the contours generated, the surface itself. Here's your alignment that goes through, your sample lines. Each one of these sample lines, when you get your contextual toolbar, you've got create a section view from that particular sample line. You can just smack it real quick over here, and let's put it right there. There's your section view of the very first one. It is amazing, and then of course you label that in the section view. I've done that with the profile itself up here. Come on. Profile in there, ground control points over here. Here's the other section views every 100 feet, what the pile looks like. And so lots of good stuff. One more, well, it's 11 minutes. I've got 4 more minutes left. I have got to show you recap. This is literally becoming, it's pushing out InfoWorks. And so I got to say InfoWorks is a promise to my buddy up in Tulsa. It's my go-to. I start every project with InfoWorks. I don't even think about beginning to do an RFP and RFQ without going to InfoWorks. But I'm finding out that with Recap, it actually is a better place to start for point clouds. If somebody hands me data and I need to start getting my mind wrapped around either the photogrammetry or the active LiDAR data, Recap is the one that gains my attention. And so as it's loading there, I'd like to offer any of this data to y'all. If you just send me an email, I'd love to get part of the data set in your hands. So off screen, there's Recap. Here's okay on that one. But just commercially starting project, this is photo to 3D. Huge aspects of taking ground photos. The sample file up here combining the terrestrial LiDAR active sensor with the passive sensor. It's unbelievable. When you start a new project, either LAS point cloud or E57, I mean any of them, but your point cloud data and then your photogrammetry data. But this is what you get, and this I'm just going to open the Chico drawing here, and this is yet the most fantastic way of looking at it itself, because a lot of times on the elevation view, just for some real quick, I got to get my settings taken care of now. I'm getting meters on that one. But geo-referenced, smart data, so much smaller and so much more effective. Another screencast is bringing this and dropping it into InfoWorks. Anyway, stay tuned. There is just the workflow on future of making things that Autodesk has come up with is just literally cutting edge. It's best in class as well as best practice, and we're just glad you get to be a part of it, integrating the tool. So anyway, many thanks to our folks up there in Frisco, Texas, allowing us to be part of this project. When we dial in and give you the volumes and the contours and go through all the volume reports, which I think we have somewhere. That'll be subject to the next screencast. This thing turned out great. Base elevation, comparing the surfaces. I have 30 seconds left on this. Anyway, yeah, surface 3, you notice that it is the combined tin volume surface. And then these are just the tin surfaces themselves. The base, you can turn off, change your view properties, water drop models. The surface management, absolutely amazing. So anyway, like I said, so much appreciate being part of this. This is what we do. And it's Tom Eckert coming at you live. Have a great day.